Welcome to everyone again in Java training session. In previous class, we have had a discussion regarding Java operators and have had some basic understanding functionalities of bitwise operations and all. So there was one thing which was uh, in confusion that day. Does anyone have idea like what we were talking that day and what was the confusion in? Anyone? No, right? So let me tell you, like at that day, we were talking about bitwise operators, and we have had a confusion in bitwise operators, like the operation was resulting like right shift, triple right shift, and right shift operators were behaving same, right? So the reason behind that right shift operator and triple right shift operator was a minute difference there, that when we use right shift operator with the number of bits on the operand side, uh, let me show you something. Hmm. So the operator which we're using is, and there was another operator, triple right shift, right? So these two operators are basically different in their concept. Like in both the operators, the bits are shifted as per the left hand operand, but in the double right shift operator, it will be shifted with zero fill from the left, but the leftmost bit, if it is one bit, that is, if it is a negative representation of a bit, it will not be shifted, it will remain as it is. Whereas in case of triple right shift, even though if it is a negative bit at the leftmost, it will be shifted with zero fill. So that is what the basic difference between these two. So in double left shift, whatever the bits you will be shifting, it will remain negative in negative number. Whereas in triple right shift, the number of bits you will be shifting, it will be converted to positive bit, because the leftmost bit will be shifted to right as per the number of operands you have defined. Like if you have specified two left shift, two right shift will happen with a zero fill of that. So that is the overall difference between these two. Now today we are going to talk about, if anyone have any question on this.
Just one confirmation, Rajesh. So
Hmm.
operands are like A and B, like
Hmm.
an operator is like plus, minus, and something. So
Right, right. Huh?
okay, okay. So just wanted to clarify.
Yeah, basically the operator are something which through which we do some operations, right? And operands are on which these operations are going to happen.
Yeah, right, right. Okay.
So that is the basic fundamental of this. Okay. So today we are going to talk about uh, fundamentals of Java again. I think you might have already gone through the fundamental classes of Java, but I'm just going to have basics of Java in such a way that it will be uh, good enough to have you understand the conceptual and architectural understanding of Java. Otherwise, it will be like writing a program won't be that tough, but understanding the concept behind that those program will be quite difficult if we don't understand how Java is behaving, what Java is doing, why Java is doing in such a way, and that is really need to be understood. Okay, so I have given it a name, revisiting Java. So revisiting Java gives you like these many things. You might have already gone through history of Java, platform independency in Java, USP of Java, those Java features, Sun Oracle deal. You must be knowing about different Java platforms, difference between JDK, JRE, and JVM, Java versions, JVM architecture, installing Java on Windows. You have already gone through understanding path variable. Why we set path variables? In some cases, the path variables are automatically set, but in the case of uh, programming in Unix, probably you might need to set Java path for your application execution. In Windows, we probably not. But if you specifically want to do something, that also possible with the help of some Java specific variables, environment variables. So those all we will be learning in this particular session. First of all, we are going to talk about platform independency in Java. I am just skipping off history of Java because that you already know. History of Java started with Oak, then there are certain changes. There was starting a specific Java version, then there was a specific Java version. So we will be talking on those with what are the feature enhancements on those different Java versions. Why those Java versions have been created? What are the different features on those versions? So initially, we are going to talk about platform independency in Java. What is basically the platform independency? Uh, as we are going through different programming languages in C, C++, when we are writing a program, basically what happens in those programs? You compile a C program in Unix environment, it will be converted into specific format, like C program is being converted into O dot extension, extension, basically OBJ, right? So what happens when you compile a C program in Unix? It will be converted into object, and then there is specific format which is specifically meant for that particular Unix machine. If you take that C compiled code and try to execute it on Windows environment, it will not definitely run because it is not architecture neutral. Architecture neutral, that means the architecture of Unix machine and the architecture of Windows machine are totally different. So those programs which are compiled on Windows machine cannot run on Unix machine, and Unix machine programs cannot directly run on Windows machines. So there might be something required to run those applications on from Unix to Windows and Windows to Unix. But in case of C, there's nothing like that. We do not have anything that we can directly run a C program created on Windows machine on Unix environment, and vice versa. And even there are cases that in the Unix environment as well, if there are different configurations, machine configurations are different. There are or in Windows environment, if there are different machine configurations, like if we have created a particular C program on x84 architecture and you want to execute it in a 64-bit architecture, or you have created in a 32-bit architecture and you want to run it on a 64 architecture, it will not, because there will be a DLL issues. there will be a library issues, right? So those compiled code will not be able to cope up with the underlying operating system, and then it will fail out there. Whereas in case of Java, when we talk, Java is architecture neutral, and that architecture neutral thing is something we say is platform independent. That means you can create your Java program at one place and can execute on different environments, different operating systems. But that can only be possible if you have underlying JVM there. JVM is Java Virtual Machine, which is required to run a Java program on different machines. The JVM architecture on different machine is different, but for Java classes, it knows that Java classes cannot be different, because when you compile the Java class, JVM compiles it, or Java compiler compiles it in such a way that all JVM architectures across the globe, across the platform, understands that code and able to execute that. So that feature of Java makes it platform independent, and that is the basic fundamental reason of popularity of Java. There are some other reasons which we talk about, but this is one of the fundamental reasons why Java is preferred and why Java is liked by uh, most of the um, businesses and development. So next we will be talking about USP of Java, that is Java features. So here we have Java features of Java. Guys, if you have any question in between, just immediately interrupt me. Okay. So I am going to discuss this in a lighter scale right now, and then we will be discussing it in while we will be developing our application in complete detail, that where we are using this functionality, where we are using this functionality, where we are using this functionality. So initially we are going to start with features of Java, where we have different features like object oriented. Java is simple in what? In case of development, it is quite simple in comparison to its predecessors like C, C++. There are some other programming languages which are much more simpler than Java, but in case of whosoever was a developer of C or C++, for them Java is much easier. So object oriented, simple, secured, platform independent, robust, portable, architecture neutral. So here we have three things: platform independent, architecture neutral, and portable. These three things are just one thing, basically: platform independent, portable, and architecture neutral. What it means: platform independent, something with an application which is platform independent, or Java is platform independent. So you design a particular application, you can easily port that to a different platform, and on that platform it runs successfully. So that is architecture neutral. So these three topics, these 3 points are only one, that is platform independent. Basically platform independent thing is portable and architecture neutral.
Sorry to interrupt. When we saying Java is platform independent, so does this mean it can run on mobile applications with Android? I mean,
In there is different Java version for those, right? There are different Java versions. But yes, if you create a mobile application for one environment, one mobile, it can run on different mobiles as well. Like if you create an application for uh, Android version. It can run on Windows. It can run on Symbian. It can run on different operating systems of mobile as well.
Okay.
Okay. So this is the Java we are talking about right now is specific to the desktop version of Java. That is server Java. That is desktop Java. Mobile Java is mobile platform Java is something different. Okay. For Android development, Google has created its own APIs to run Java applications on Android environment. Okay, to give support on that environment. So Android is basically a Linux, and those applications, if you install on your Windows environment as well, probably that will also run. Okay.
Okay, thanks.
uh, just want to let you know, Java, Android Java is specifically meant for Android operating system only, whereas Java, that is mobile Java, Java has different version through which we were earlier designing Java applications for mobile, but that is now obsolete. So mobile applications are not developed more on Java. There are uh, faster frameworks, good frameworks through which we design mobile applications like Ionic, like Angular, basically, and with the help of React, for which the classes goes on, like React Native, and some other. So Java is obsolete for mobile development, but using Java APIs, Android had created its own Java version that is to create Android mobile applications. Okay.
Yep.
So platform independent, portable, and architectural neutral are one thing. We just understand it as one concept. Then we have Java is dynamic, Java is interpreted. Interpreted is also comes under architecture neutral. So we will be talking about that, but that has a connection with high performance. Java is interpreted and it is high performance. So we have JIT for high performance of Java. Then we will be talking about multi-threaded, distributed. So Java is multi-threaded. There are multiple threads in Java through which we can utilize the maximum CPU and uh, make our application run in parallel. Like give it a feel of that our application is running in parallel. If it is running on a parallel system, definitely it will be parallel. But if it is running on a single core processor, it will be on a CPU scheduling, but gives you a feel of running parallel. Okay.
One thing. So it's mentioned Java is simple. I mean,
Mhm.
features simple, but I heard Java is most difficult language.
That's what I'm saying. That's what I'm saying. Java is simple for those who are coming from C and C++. Right. If you are comfortable with Python, if you are comfortable with Smalltalk, if you are comfortable with Scala, the different programming languages, you see there are syntaxes in Java which are unnecessarily written. That looks like, oh, why this is that much complicated if it can be written in such a small way. But Java has its own writing pattern, its own coding pattern. So that coding pattern sometimes make you feel like Java is difficult, but there is some logic behind it. So we are just comparing it with the earlier version of programming languages, C, C++, Fortran, or some other programming languages. Those were quite complicated to write. So in that perspective, we talk Java is simple. But yes, in future languages we are talking about, the Java is bit complicated to understand. But if you understand Java properly, if you understand Java's basic concept, the architecture of Java, the features of Java properly, why Java is robust, why is Java secured, what are the security features in Java, what are making it more robust, why, what is Java object-oriented concept, how Java multi-threading works, how Java's high performance work basically, and how we are making Java dynamic, and what are different implementations so we can make it distributed. So you will be pretty comfortable in writing a Java code without any problem. So understanding concept is very much required in Java. Got it?
Yeah.
Okay. So we are just skipping object oriented as of now. Simple we have discussed. Object oriented we will be talking at last. Now we are understanding those features which we must know initially. Theoretically we must know, and then when we write program at later stages, we will try to implement those. Okay. So secure.
Sir,
Mhm.
can you go back to the previous slide?
Sure.
Here is a point called multi-threaded. Can you explain more on this? What actually multi-threaded environment is?
Multi-threaded.
Multi-threaded environment. What actually
Okay.
is happening in multi-threaded?
Okay. You have worked on DOS.
Not really, not so much.
Okay. Have you ever run a command on DOS?
Yeah.
Okay. So when you run a particular command in DOS, what happens? That application or that command, until that command completes, you won't get a prompt to run another command.
Yeah, that happened.
Okay. Right. So what
Hmm.
is that? That is a single threaded operating system. That
Hmm.
at one time only one thing will be executed, not more than one. Whereas in Unix, if you talk about Unix operating system, even with the command prompt, you can write multiple background processes with the help of ampersand symbol on that. Like you are running one command, and then you can put ampersand that this should be this should run on background. This should run on background. This should run on background, and there will be one thread which will be running on foreground. So Unix provides you a multi-threaded environment where you can run multiple processes, multiple applications, or multiple processes at one time.
Hmm.
Okay.
Yeah.
I'm talking about processes, and then we will be talking about threads,
Hmm.
right? So
So,
Unix, and
hmm.
in each particular process, we could have multiple threads. uh, on a particular application, there are multiple features. So all features can be simultaneously running, or there will be one feature will be running. In Windows operating system, we see the Windows provides us a multi-threaded environment. In that, we can run song, we can play video, we can search on Google, we can run a particular application, Window, Word, Excel, PowerPoint, or anything at the same time. Right.
Okay.
How that happens? That is with the help of a multi-threaded. That there are multiple threads which are controlling these different multiple processes.
Okay.
Okay.
Yeah.
And within each process, within each application, there will be internally multiple threads.
Okay.
Okay.
So threads, combination of threads can make a process, right?
Exactly.
Okay. Okay. Right. Nice.
Okay. So here, the first topic we are covering is secure. Java is secure. As we have heard a lot on this, that Java is secure, but very less people, even I have seen lots of experienced developers, lots of developers those says that Java is secure, but they still don't clearly understand the security concept of Java. Why Java is secure and what makes Java secure. So it is good that we should understand this concept before going for any development on Java. So Java has security manager concept. Java के अंदर Java has security manager concept which keeps its execution within a sandbox to prevent any harm to the system it is running. So first of all, we are talking about a particular system on which Java application is running. So Java application runs within a boundary so that it will not harm anyhow to the underlying operating system or the system. It should not create any problem with other processes, right? And it doesn't as and what that sandbox is. That sandbox is its JVM. That JVM provides a particular memory, a particular heap, a particular area to run that Java application, and it will not make that particular application to do any kind of problem with other applications running on the system. So in that case, this is secure. And there are different things. No buffer overflow exploits. Now, what is this? No buffer overflow exploits. In C, how many of you have done C programming, please?
I've done
You
C.
have done in
Yeah.
C programming. So you might have seen that you declare an array in C programming language of character. Let's say you have created a character size of character array size of 10. Okay.
Yeah.
And while inputting some value, you have only entered first 8 characters.
Yeah.
So what will happen
Okay.
with those two? There are some special characters comes generally in C. It like if you print that complete, it will be fetching some special character from the memory, like some
Garbage value.
garbage values.
Yeah.
So here we do not have that kind of problem in Java. Whatever you define, whatever space you define, it will not contain garbage value from the memory, because Java has some kind of features, that is garbage collection, which collects the garbage from the memory and makes it clean. And also it has the feature of no buffer overflow, that you have created a particular buffer size. On that buffer size, if you do not have filled the complete buffer, it will not go beyond that and bring you some data for unnecessary data, unrequired data, that is a garbage data, right? So it cannot store data outside its fixed length memory boundary. Got it? Any question on this?
Sir, but here it is written no buffer overflow. So I don't understand how it is overflowing. I mean, why is it named overflow? Is it data is leaking somewhere, or
Exactly. In case of C, if you don't fill it completely, so wouldn't that memory spaces or those data is leaking?
yeah, the garbage values are leaking to the array memory?
Definitely. So here we do not have that kind of issues, right? So those,
Yeah.
yeah. So that is not going beyond the boundary. Okay. Now, bytecode verification. In case of Java, when you create a particular Java program, it gets converted into a a bytecode, that is a class file. So what that class file is, basically Java's class file is an intermediate code, a bytecode, a code which can run on different platforms if there is an underlying JVM. Right? If the JVM is there, your code bytecode will run. So what this bytecode verification is, basically the bytecode verification is that if you create a java.class file, while compilation, the Java compiler puts some like writes bytecode in such a manner that JVM, all the JVM environments across the globe, across the operating systems, across the architecture, they understand that bytecode. They know that what you can say in um, basically the design of that bytecode, that how those bytecode should be written and whether they are intact or not. So in some case, if there is any entry, any malfunctioning into that on that particular bytecode, somebody has opened that bytecode and created some input some special character, some value into that, or through some other virus programs, if its design is changed or some special values entered into that, JVM immediately understand that. When you interpret it with the help of Java interpreter, JVM immediately understands that, oh, there is some change in the bytecode. So this is not a genuine bytecode which I should execute. So in that way, it saves that particular class from execution and saves the underlying operating system. Okay, so bytecode verification is one of the strongest feature which makes Java secure. Okay, then we have security related APIs. In Java, we have security related APIs which makes our Java code secure. What we can write security related APIs, we can utilize those security related APIs while writing our own code, through which we can make our code specifically to be like uh, a case of some malfunctioning or some attack, right? So with the help of these APIs, we can write a more secure code in Java. Stack corruption. So what is stack corruption? Can anybody like as all must be somewhere related with uh, technology background? So can anybody tell me what stack corruption is? What do you understand by stack corruption?
Stack is something like first in, first out, what we learned in um,
Okay.
data science.
Exactly. Stack operation is first in, first out. No, last in, first out. Basically, it is
Yeah, sorry, last in, first out.
right, because stack is an open-ended array. Basically, it is closed at the bottom and open at the top. Whenever you insert a value, it goes to the end of that stack, and whatever you entered into as last, it will be on the top. So whenever you pull it, the last value will be pulled. If you want to access third value from the stack, you have to pull out fifth, fourth, and then you can get the third value. So that kind of operation happens in stack. So this is basically a stack operation. Now, what is a stack corruption? Stack corruption is a phenomenon. Let me read this definition, and then we will talk about it. Stack corruption is a phenomenon in which some memory locations at stake are accessed unintentionally due to wrong coding, leading to change in values at those memory locations. Since the data corruption happens on stack memory locations, hence the term stack corruption. Okay. So when you write a particular program, what happens in general sometimes that you write your program without understanding its architecture, the programming language or the underlying operating system architecture. So while writing that, you sometimes skip the basic fundamentals of the programming language, and that is what handling of memory. When we were writing in program earlier, at earlier stages in C programming languages, we were not usually releasing the memory. We were occupying the memory, but were not releasing the memory. So that is a bad practice in any programming language. So what was happening in that case? So if we don't release the memory, those memory are still in like still occupied, and that can be a cause to a virus attack. That could be a cause of memory leakage. So those were happening in C programming languages. Later on stages, we were started using memory allocations and then freeing the memory. But still, there were some conditions. There were some issues while doing that. If we skip something unintentionally, that was again a threat to programming. Now, stack corruption is kind of like unintentionally when we are writing a particular code that uh, allows the external entity to change the values at memory locations, or anyhow our program is unintentionally some other program of ours only, or some other piece of code, some other thread is unintentionally doing that change into the stack. So that will make that data, that particular stack area, that particular memory in the stack corrupted. So when you pull down the value of stack, when you pull down the value of stack from the first thread, uh, you will get a value which you have not entered, which you have like skipped, or like you were not expecting this value. Why? Because some other entity has changed that value, removed that value, done some operation with that value. So that is what stack corruption basically. So in Java, we have that kind of security, that stack corruption is not possible. That if particular thread is occupying a particular stack, doing some operations with the stack, no other threads will be able to uh, interrupt with that stack, because for each individual thread operation, a different stack is being created in memory. So each thread, each operation is having a different stack of memory. Okay.
Sir, but creating a different stack every time will also lead to, memory consumption, don't you think?
No,
I
no.
mean, every time you're creating a thread, you are uh, creating a new stack, and
And what is the life cycle of a particular thread? Do we
uh,
keep those threads for whole life of the application? No. The threads are being created to do a smaller piece of execution, to do a smaller piece of code execution, right? It is not a complete process. So
okay,
that is why in a particular process we have thousands, lakhs of threads. Those can be generated.
okay.
So those
So every
thousands and
time,
lakhs, yeah. For, and a particular thread, if it is, if we talk about a single memory model, a single core CPU, then at a particular time, a particular thread will be executing on the memory, sorry, processor.
okay, yeah,
Even though it is CPU scheduling, time scheduling, we call, but at one particular time, only one thread will be executing on the processor. So for that particular thread, the stack is created. The stack value is created, and not for others. So that happens in that particular way. But when we talk about parallel, so there might be like in today's systems, we have 8-core processor, 4-core processor, dual core kind of processors. So in those core processors, we can do some kind of parallel processing,
yeah,
right? So for that, there could be n number of thread executions at the same time.
Correct.
Okay. The next thing which we have is it is having no pointers. So Java does not allow you to create pointers. And that is what the Java's biggest achievement over C and C++. Why? What was pointers doing? In C programming language, if we have to interact with memory directly, what we were doing, we were creating pointers to get into a particular memory area in C, put some value or pull some value. Doing some operations on memory directly, we were using pointers. So if we have pointers available in C for our programming language, somebody else can write with the help of pointers. So he might be more intelligent to understand the pointers as compared to me. So he would be writing the pointer code in such a way that it could interact with my memory areas, my program, the program which I have executed, and the memory area which I am using. He might do some operations or do some manipulations with my memory area because he do have memory access. He can directly interact with that. Or if anyhow I am leaking some memory area, I'm not freeing using and not freeing that memory. So that will be a hole in our program, and somebody else can enter with that memory hole to our program and do some manipulations. So knowing such things, Java has decided not to allow the programmers, the application developers, the developers which will be using Java programming language to have functionality of pointers. Although as Java is developed on C, right? C and C++. So they have internally used pointers. They are interacting with the operating system with the help of pointers, with the help of like memory, with the help of pointers, but doesn't allow you to write pointer program. Although in place of that, Java has provided you lots of APIs for memory management, lots of like fast memory processing. We can say that Java is bit slower in comparison to C or C++ programming languages because they are directly interacting with the memory, they are directly interacting with the operating system. They right. But when you are going to achieve security feature, that security feature is much more important than a bit of lack in performance sometimes because even in C we have multi-threaded things. In C++ we have multi-threading, we have sleep method or something. But Java provides you some APIs through which you can directly do whatever the operations you were doing with C. Like collection APIs you have lists, variables, maps, and with the help of you that you can do anything. Right? You do not to explicitly create an stack with the help of an array. You have vector. You can have list. With the help of that, you can create stack or array or queue or whatever. Even Java is already providing you some queues, blocking queue, priority queues as well. So these all features are there in Java, which makes Java secure. And who is responsible to manage this security? JVM. JVM is responsible to manage this security for you. So here we are seeing security measures for Java. Java has concept of exception handling. Java has concept of garbage collection. Java has concept of reference casting, bytecode, security, like it protects from security attacks. It has having a security model. It has defined order execution. It has access control functionality. It is like basically have reusability, code reusability. It doesn't have pointers. So these are different security measures of Java. When you write Java code, you will be able to understand those features in more detail. Now, the second thing we are talking about, robust. So what do you understand by robust? Anybody can tell me what do you understand by robust? Anyone?
So
Robust
robust.
is, yeah,
Mhm.
Yeah, okay. You can.
robust is something which is scalable, and it is strong, and it is rugged, something like that.
Okay. Robust is scalable. Uh, how? Can you define that scalability, and what is scalability basically?
Uh, you can go from starting with small numbers, something like that, when you handle a small amount of data or small amount of users, and
Mhm.
you can when suddenly somebody uh, you expect 10, and suddenly 10,000 or 10 million come inside, then
Right.
that scale of that Java is capable of handling that.
Yes, that is scalability basically. That is
Yeah,
a scalability concept of
yeah.
Java.
So for that you need to have robust capacity to handle this. You need to be capable enough to handle scalability, durability, and all those things. It should not break down.
Exactly. It should not break down. This is the main concept behind robustness. That robust thing should not be written like in such a way that it will, on any specific requirement, it breaks down. Oh, I cannot handle this. Oh, I cannot handle this. This cannot be handled. So this kind of thing should not happen. So that is what the fundamental concept of Java, that Java can handle scalability. Java can handle lots of other things which other programming languages cannot. It is having memory management, automatic memory management, that is garbage collector. So you do not need to worry about maintaining the memory, because as Vikram has told, that scalability, when you scale your application, that automatic memory management is very much required. That is very important feature, right? When you are writing your Java program, Java doesn't allow you to write anything in any format. In C, we do not have strong type checking, where in Java we have strong type checking. With the help of latest Java APIs or latest Java implementations, we are having strong type checking. Like say in generics also, we uh, as per the implementation of generics in Java, this is having strong type checking. In creation of primitives, type conversion of values, the Java has a strong type checking, that you cannot convert one form to another form easily. For that, you need to understand strong type checking concept of this. Right. In C, in if condition, you can put zeros and ones, true and for true and false. But in Java, it doesn't allow you. It allows you to have a Boolean value, that specific type. You should, for us, zero is a numeric value. But if we put it in if in C, zero is treated as a Boolean value. Like anything which is 0 is treated as a Boolean value false. Anything which is above 0, even though it is -1, that is non-negative. Like non-negative is 0 is false. Anything negative, positive, but not 0 is treated as true in C. Whereas Java specifically asks you to define a particular exact type which it should take into that if condition. If you don't provide that, it doesn't compile your code. So those kind of things Java uh, bounds you to write. Otherwise, it will not allow you to compile your code. And then the next feature, it is having exception handling mechanism. That is again a very important feature of Java. Exception handling mechanism. What is exception handling? Exception handling is that whenever you write a particular code, you might know that, okay, my code at some point can create, or at some particular value, it might fail. So you should have a precautionary measure. You should have something that should be that particular your particular code will be written in such a boundary where it can be handled easily, rather than abruptly terminating your program. Right. So exception handling is a mechanism through which you can protect your piece of code so that it should not immediately breaks down your program, and you have a capability of handling that particular issue in the help of in the catch block or finally block. So exception handling mechanism is definitely very important thing. There are specific Java classes which are already providing you some exception implementations. So whenever you are using those methods, those APIs of those classes, they bound you to have a, block where they will be written, like exception handling block where they should be written. Otherwise, they will create a compilation problem. So there are two types of exception handling happens in Java. That is compile time as well as runtime. So those we will be understanding at the time when we will be understanding exception handling mechanisms. Okay. Then we have no multiple inheritance concept. Multiple inheritance. Earlier in why I am comparing it with C, because those all are the features which was in C, has like features of problems in C or C++ resolved in Java. So I am comparing everything with the C or C++. So in C++, while C++ was an object-oriented programming language, like it was not again a complete object-oriented programming language. There were virtual functions, friend functions. There were some other concepts, writing code outside classes, creating primitives. Java is also not a fully object-oriented programming language because it has some kind of those things, but it has majority of object-oriented concepts. That was what we generally call as object-oriented. Like Java is an object-oriented program. So in multiple inheritance concept in C++, what was happening? What is multiple inheritance concept? That a particular class. Um, mm, let me show you. Okay, so I have class parent or parent 1 and parent 2. Now my class child inherits the features from parent 1 and parent 2. So this is what called multiple inheritance. If my child inherits the features from parent 1 only, then it is called single inheritance. But if my class is inheriting features from two different classes, that is what called multiple inheritance. So what is the problem with the multiple inheritance? It is a feature that we are inheriting multiple features from different classes, isn't it? This is yes. If we are getting multiple features from different classes, this is good. But the problem exists. If parent X has a feature called X and parent Y, parent 2 is having a feature called Y, and then it is good that child is inheriting the feature of parent X as well as the feature of parent uh, 2, that is Y. Now the problem exists when there is a feature called Z in both classes. Although their implementation is different, but in both the classes, there is a same name function with same type of parameters, with same type of return type. So here, child is confused that if I inherit Z, then whose Z should I inherit? Got it? So the
Yeah.
biggest, yeah, so the biggest problem here is, oh, X, Y is fine, but oh, Z, who's Z? So in that case, C was allowing you a different thing, that okay, you can access both whatever Z function you want, but you cannot inherit it in such a way. You have to explicitly call parent 1 and then the scope resolution operator and then Z. Okay, that was also okay, fine, great, not a problem. Now, if I am inheriting child 1 and child 2 from, like, this particular, this is now a parent of these two childs. So child 1 is inheriting a feature of X, child, and then this is X and this is X. This is also X, then this is Y, and this is Y. Okay, and then you have some other requirement, child 3, which is interested to inherit child 1 and child 2. So what is happening here, that you can create such kind of architecture in C++, and in that case there is a confusion at every stage. So for every stage you have to use scope resolution operator, and child 3 is confused. Oh, okay, I want to have X and Y, but X and Y is coming in both. So here there is a kind of problem that it is creating a diamond kind of a structure at each level. When we go down at level by inheriting parent and child and parent, then it will be a diamond kind of structure, which Java doesn't allow. Java says, no, nobody, you do not need. How could a child can have two parents? Parent means parent. Parent means mother father. That means you have one set of mother father. Can you have multiple set of mother father? Definitely not. So Java says no, you do not. You cannot have multiple set of mother fathers. You can have only one set of mother father. That is your parents. That is your parents. You can have child like this kind of inheritance. Parent is having child. Now this particular child can be a parent of child 1, and this can be a parent of child 2. This can be parent of child 3. So this is kind of design Java allows. Java doesn't allows multiple inheritance. So it has come up with a concept that no multiple inheritance concept. Although some people says that Java allows multiple inheritance with the help of interfaces. So when we understand interface, we will see what that mean basically. What is a multiple inheritance with the help of interfaces? Is it really an inheritance, or it is just a theoretically inheritance? And what is the benefit of interface when we are using in place of like along with the classes? Okay, and robust as it is controlled by JVM, its all execution is handled by JVM, so it is robust. Now, we have already discussed secured and yeah, and robust. Platform independent we have discussed earlier. Now we are talking about multi-threaded, and then we will move to performance. Okay. Now, multi-threaded even we have discussed earlier, but what multi-threaded here is? Multi-threaded is a Java feature that allows concurrent execution of two or more parts of program for maximum utilization of CPU. So, what was happening in the case of earlier programs when we did not have like earlier architectures when we did not have had uh, this kind of multi-threaded environment, multi-threaded core, multi-threaded CPU operating system. In that case, if there are different programs to be executed, they have to wait explicitly for execution completion of one program, because one program was executing, consuming the whole CPU, even if it is waiting for input. Let's say I have written a program which is waiting for an input from the user. User is not inputting it for 10 minutes. That is holding the CPU, that is consuming the CPU, that is consuming the buffer for 10 minutes. That means for other programs waiting that I want to execute a program, I want to execute a program, but I do not have CPU available. So how can I execute? So this has overcome with this has come overcome with the multi-threaded operating system. So multi-threading is basically a responsibility handled by operating system. It is not on the programming language that it handles the CPU scheduling, it handles time slicing or something like that. It is all depends on the underlying operating system. But with the help of programming languages, we can create our threads. We create our threads, we can uh, send it for execution, but it is on the mercy, it is on the implementation, underlying operating system implementation, that how it handles that particular thread, those threads, how it schedules, because every individual operating system can have a different architecture for handling the threads. So a same Java program, which is a multi-threaded Java program, might behave differently on different operating systems. Why? Because on those different operating systems, the multi-threading architecture is something different. So you must have core understanding of multi-threading before using this functionality. Because if you do not understand multi-threading, it will be a problem and it will behave very differently on different operating systems, and there will be no use of multi-threading. So, so each part of such program is called a thread. Like whenever you create a particular program which has multiple parts, so each program is called a thread. So threads are lightweight processes within a process. So what is process and what is thread? We will be understanding it in more detail when we will be understanding multi-threading. But as an overview, we say process is a coarse grain. Coarse grain means agar if we talk about a grain of wheat, for example. So this is the coarse grain, and when we break it into pieces, we call dalya. So that is fine grain pieces. So from a particular coarse grain, there can be multiple fine grains. Okay. So that process is getting a particular memory space, and all threads execute on that particular memory space. So within that memory space, if the things are executing, that is light processes. So threads are light processes. When a particular thread from one process wants to communicate to other process, thread of other process, that is a costly process. So we will discuss that in more detail. In the multi-threaded environment, how we create a multi-threaded class in Java, that is with the help of extending a thread, and there is another implementation that is with the help of runnable interfaces. And in advanced features of Java, we have some more functionalities on multi-threading that we will be understanding. Guys, I am gonna teach you Java 1.5, the functionalities of Java 1.5. Earlier, what was there in Java 1.4, we will be understanding. Then from Java 1.5, when we will be in a good position, good shape, then we will be moving directly from Java 1.5 to Java 1.8. And that is Java's Stream API, Java's Collection API, Java's like functional interfaces and lambda expressions. So those all we will be understanding once we will be through with a Java 1.5, so that you will be having a different, you will be having a clear understanding. Okay, what we were doing earlier and what we can do now, how we can implement it. So next is high in performance. So how it is high in performance? Java is interpreted. Interpreted means what? That when we run a particular Java program is a class file again. But boys need to understand that Java's class is not directly executable on any operating system. It can execute within the JVM, because JVMs are responsible to provide it memory space. JVM is provide it to interact with the hardware. JVM provides functionality to interact with the console and everything. And there is a specific memory management in JVM that JVM handles to create objects, to create uh, primitives, to allocate spaces for functions, for classes, static classes, everything. So that whatever we compile with Java, that is a dot class file, and that dot class file runs on within the JVM boundary. Now, to run a particular Java program, we use Java interpreter. Java interpreter is responsible to send that bytecode interpreted line by line and to the JVM. JVM sees those, understands those, creates whatever the memory space is, create whatever like uh, stack frames it requires, threads it requires. It creates everything for you, and then it allows you to interact with the operating system. So how Java, like earlier, Java's performance was little slower. Then there were complaints like people were saying Java is slow, Java is like takes more time to execute because it was interpreted as a whole, as like line by line, and then executed. Now, with the help of Java enabled high performance, that is JIT, just in time compiler. Just in time compiler makes your Java application much faster in like execution. So, how just in time compiler helps? Just in time compiler is done like JIT helps in compilation, the compile code on demand basis. Demand basis means what? That when a particular, like you have a piece of code where hundreds of methods are there, like a particular class which is consisting of hundreds of methods. So while execution, if you load all methods, if you uh, uh, allow memory spaces to all methods, or like load all the method in the memory, definitely it will reduce the performance of your execution. So just in time compiler comes here in picture, and whatever the demanded, whatever the method requested to execute, let's say if I have written method for calculation of sum, and that particular sum method is called to execute. So just in time compiler will load that particular method at that particular time, executes that, and it immediately compiles that, and then makes it available in memory, that it like if somebody has understood the concept of uh, prepared statement in Java, that some statements which are sent to uh, database pre-compiled, that pre-compiled statements are residing in memory, so they do not need to recompile. So just in time compiler makes those uh, statements compiled and make it available for you, that whenever that particular piece of code is required, that will it will be providing you that compile. Okay, for the first time it does the compilation for you, and then keeps it somewhere so that it will be easily available. You can directly interact with that particular compile piece of method, and that reduces the further compilation of that particular piece of code or piece of function, and in that way it increases the performance of your Java application.
Hello.
Yes.
Suddenly there is no sound.
Hello. Are you able to hear me?
Yeah.
Okay. So what and how it happens? Java source code, which gets compiled, it gets converted into a bytecode .class file. Now at runtime, JIT comes in picture. The .class file, with the help of JIT compiler, it compiles those methods required. Like it doesn't compile all the methods, it compiles those methods which are required, and then creates that into, and then places it somewhere, so that if it is further required, it will be available. So it compiles that code and prepare its native code, and then keeps it somewhere in the memory. and whenever that particular method is required, it will immediately provide you that particular method, and that will be executed immediately. So you do not need to make it native all the time. So just-in-time compiler helps in doing that. Earlier, it was happening that for each and every execution, a method execution happens, and then that is cleaned. Now, if you have again requested that particular method, that will be recompiled and that will be reconverted into native code, because Java doesn't provide you exe. The Java provide you class file. The class file, an execution of class file, everything was converted into understanding of operating system, underlying operating as per underlying operating system, so that underlying operating system understands that and provides you whatever required. So that was the biggest problem earlier, and that was making performance decreases of Java. With the help of JIT, that is increased. So the next topic from this, we will be discussing this after a 5 minutes break. If you have anything to know, any question generates in your mind as of now, you can ask me immediately, and then we can go for a 5 minute break. This class will go till 11, and we will cover these topics today itself. And from next class, we will be starting with the object-oriented concepts.
Sir, I have a question on a high performance slide. Can you open that?
Okay, just give me a second. Yeah, which slide you're talking about?
High performance slide.
Okay.
Yeah. So here you said that the code is compiled and we can code is compiled and is saved in the memory, which is used whenever it is redemanded again. So is it not using I mean, is it not consuming memory while application, when application gets live, it
There is a stack. There is a method stack.
stack method.
Yeah, method stack. In when we understand memory architecture, we will be going through that method stack as well. That all the methods which are precompiled, those will be staying in a method stack, and from that particular method stack, it will be picked up, and that will be allowed to execute the particular code.
Okay, so during the whole life cycle of the application, that method stack is always used, right?
Yeah,
Okay,
basically.
okay, like that. Okay, now it's clear. Thanks.
Okay. Any other question? Okay, well, make your questions if you have any. I'll be continuing in just 5 minutes. These slides will be available on GitHub. So I'll share once this class will be over. I'll share the GitHub location on React like group. We have React Java group, so you can get that slide on GitHub. Okay. Okay, let's start.
Before we going ahead, can we go to secure feature of Java?
Yeah, sure.
Uh, 1 second. Yeah, secure feature of Java.
Hmm.
Yeah, so one it's saying a stack corruption. So isn't it should be a stack corruption free?
Sorry.
I mean, heading should be a stack corruption free, right?
Yes, basically, yes, it is.
Okay, so I was confusing with this heading because you said it's I mean it's corruption free, so heading should say the same. Okay,
Okay.
yeah,
So this is like just a topic, and we should understand the concept behind it. The stack correction, it restricts you so that the stack corruption will not happen. Okay.
yeah, okay,
Now we are talking about the JDK, JRE, and JVM. This is very, very, very important to understand because some people talks JDK as JRE, JRE as JVM, and uh, they even don't understand what basically the JDK means, what basically JRE means. So when you develop something, when you develop a particular code, for developing a particular code, you need to have a development environment, a development kit, a kit through which you can develop a tool set of tools which are required to develop your code. And if those tools are not available, you won't be. So Java comes with a set of those tools that, hello, everybody getting right? I think. Um, are you able to hear
Yes,
my
yes,
voice?
yes, yes,
Yeah,
yes.
yeah, yeah. You are audible, sir.
Okay.
we can
So,
hear you.
so Java comes with a set of tools which we call as development tools, and it is having a set of libraries as well. So, with the help of development tools, we develop our code, and with the help of uh, libraries, set of libraries, we execute our code, right? So, JDK is a combination of JRE and development tools. We will understand that in more clear when we start developing code, but still you need to have a clear mind that JDK is nothing but a Java development kit, which consists of JRE, Java runtime environment, as well as development. Whenever you write a particular code, you need to have explicitly a runtime environment where your code should run. But JRE does not consist of those tools which JDK has. Like your code cannot be compiled with the help of JRE. You can only compile your code with the help of development tool. You have a Java C compiler and Java development tool, but in JRE you do not have. Let me show you something. When you install Java, it will be available here. You see there are JRE and JDK. First of all, we get into JRE. So JRE is having a set of libraries. Okay, this is rt.jar, set, deploy, Java WS. So these are the set of libraries, and these are the set of commands. You can see there is a command called Java, java.exe, java.exe, but you cannot see java.exe because JRE is only responsible to provide you an environment where your code can run. That is a runtime environment. Okay. And when we talk about JDK bin, we have different commands. You see Java, Java P, Java H, jar, applet weaver. You can see Java C command, Java C.exe, and as well as Java. So Java JDK consists of bin and JRE. That bin with the development tools and JRE to let your program run. Okay. So again, the JDK and JRE, it's a combination when we talk about JDK, JRE and development tools. Now, when you run your program, you need a set of libraries to execute, libraries to support. In C also, when you were running your program, you were required some support of libraries. Let's say when you were writing a program, hello world. So you were using printf function. Printf function comes from a standard input-output header file, stdio.h. So that stdio.h, where that exists, that is a header file which whose functions, whose compiled functions are like it is stdio.h is having a reference of a particular DLL. On that particular DLL, that printf function body is written, and we are using, when we are including stdio.h in our C program, that means we are interacting while compilation process. It does a linking with the DLL, and then once that linking is completed, our exe getting generated, and then we can further execute that exe. So exe consists of those DLL as well as your source code in compiled format. Similarly, in Java, we have some libraries which we import. There are some standard libraries of Java. With the help of, we create our own applications, like say console related things. We want to print something on console. We want to get some input from console. We want to do some other operations like collection APIs or some other APIs. If we want to do all those, then we need those relevant libraries for development as well as for at the time of execution. So those set of libraries is available within the JVM. So JVM is like JRE is basically the Java virtual machine that provides you that environment, that bowl on which your Java code will be executing, a container on which your Java code will be executing, as well as the set of classes or libraries those are required to execute, to let your program execute. So JDK, combination of JRE and development tools. JRE is a combination of Java virtual machine and set of libraries. And Java virtual machine is the core which is responsible to interact your code with the operating system. Okay, because after all, operating system is responsible for each hardware which we are utilizing with the Java class. We are utilizing console to show our output. We are utilizing console, keyboard console to take our input. So all these interactions are done with the help of JVM only. Any question on this? Moving forward.
So in short, JDK contains everything. JRE, JVM, development tool, library class, everything.
Yes, exactly. JVM is a combination of everything. Sorry, JDK is a combination of everything. Okay, because JRE, as I've told you, see here, you can see my screen right now clearly.
Yes.
Okay, so you see that I am into a folder called JDK 1.7.0 _79. So what is there? This is JDK which is having bin, db, include, lib, src folder, and as well as a JRE folder. So JRE itself has bin, lib, and in this bin we have commands, that Java command and other commands, whereas and as well as the libraries, the DLL files. Whereas in lib you might be seeing different libraries, and you will be seeing the JVM launcher. It's a JVM, like you will be having JVM. JVM.dll. There must be there exists JVM which provides you that environment basically. So this is a combination of JRE as well as that particular.
Isn't it virtual machine? I think it's not existing.
Virtual machine not existing means?
I mean, physically not there, but it's execute.
Yes, if we go with the name Java virtual machine, so it means that it is not physically available. But what? Physically not available means there must be some code which is running and creating an environment of creating a virtual environment, right? That it is running over operating system and providing a behavior to Java code like that you are running in operating system directly. So Java code thinks, okay, I am running on operating system, but actually it is not. It is running on a virtual machine that is above operating system, which is sending the message to operating system or receiving the message from operating system for the application. Okay, Java classes which are executing. Now we are going to talk about different Java versions, and what else we have today. Then we have Java architecture, but it will not be possible to complete this whole Java architecture today. So we will be continuing this Java architecture in the next session. Today we will be talking about Java versions and a fundamental of JVM architecture specifications, and then we will be moving further in the next class. And hopefully I may not be like whosoever is available in the next session Saturday,
I'll
because
be.
yeah, you will be. And okay, because there could be a possibility that I might not be available for the next session, but I'll try to manage it, and because I'm going out of station. uh, so if anyhow I'll be able to manage you, I'll update you in the group, and if it is not, then I'll also update, so that if possible Anjal can take the session, or we can skip that session for some other day. Okay. So this is not the complete set of Java versions we have. There are different other Java versions, extended Java versions have come already, but the major changes we have seen till this Java version, these Java versions, and from Java 8 version, Java is completely different. That the writing pattern of Java code is changed, although it supports the previous writing pattern, but from the latest Java 8 version, writing pattern is changed. So different Java versions we have. It was started in like 1996 with the initial release, that was JDK 1.0, and it was named as O, as you all know. and it was having a very limited set of libraries. It was like initial Java version. Then from Java 1.1, there are some other set of libraries added to that. That is reflection, JDBC. JDBC is one of the very important feature. Reflection is one of the very important feature. With the help of reflection, you can do proxy implementations, and with the help of JDBC, you can interact with the database. Inner classes, that classes within classes, that was also very concept. In the case of inner classes, we can have anonymous ones, anonymous implementations, and you can create on the fly classes. Then you have had RMI implementation, remote method invocation, that you can, with the help of this, you can create invoke a method which is running on remote machine. That is also like remote machine means on a remote virtual machine, and with the help of this you can invoke that. Then J2AC 1.2, it was named as playground. Playground, playground for whom? Playground for the developers. That the developers, I am bringing you something new that you can play with. You were facing some issues in handling the map, in handling the dictionary. I am giving you a set of collections. So from 1.2, it was named as J2 SE 1.2, Java 2 Standard Edition, and it was having features kind of collection. Collection is a set of libraries. Like in C, we were having linked list, linked list, vectors, like doubly linked list, singly linked list, queues, stacks. So with the help of collections, we can do implementations of for those. Then from 1.2 also, JIT has come, and string memory map has been like implemented in this. So we will be understanding string memory map and concept of uh, pool, string pooling as well. So all those we will be understanding when we go in the application development. 1.3, from 1.3, that is Curstal, that was again an important version, but it was only come up with one of the important feature, that is JNDI. And yeah, it has come with an JNDI, Java Naming and Directory Interface. Java Naming and Directory Interface is again one of the important features through which we can communicate with any context uh, through the naming and directory interfaces. So that is one of the important features. Java indexing, Java sound. We can skip that off right now, and because those are very less used. From J2AC 1.4 Merlin, we have assert keyword introduced. Assert keyword is one of the very important feature that has been introduced in 1.4 to test your applications. With the help of assert, we can do our code test, and uh, we can verify something, some output against the value which we were expecting. So assert statements are basically used in that. Assertion basically are used in that. Then we have regular expressions in this regex. We were having exception chaining, and exception chaining we will be understanding at the time of development. Java 2. Java 1.5. Java 1.5 is also known as J2SE 5.0. That is called Tiger. It was introduced in September 2004, and it has come with some of very important features. Those are generics. Those are very important features called generics, auto-boxing, and enumerations. Generics, as I have told you, that is very important for type safety. Autoboxing is wrapping up the primitive types into its wrapper classes and then automatically wrapping up, or autoboxing is converting that primitive into its parent wrapper type, and then vice versa, converting from primitive to wrapper to primitive type. That is specifically for storing that primitive value into collections, because collections only accept objects. So if we convert that primitive value into wrapper and create and store it into um, collections, that collections accept that. Otherwise, primitives cannot be accepted by the collections. Hello, anyone? Aman, you want to say anything?
No, no, sir.
Okay. Then we have enumerations. Again, one of the very important features. Then enumerations we will be again learning while the implementation. Then Java SE6. Java SE6, that is Mustang. Mustang version was introduced in 2006. Java was initially under Sun Microsystems. Sun Microsystems was a community of developers, a company which brought this Java application for the community as an open source. Later on, that has been acquired by Oracle. At a certain point, at till certain point, that was available for community, but later on, Oracle has started its own closed box development. Although the source code is still available, you can work with the source code and do whatever. Like you can create your own Java implementations with that, or you can customize Java code with that. But that is not included. That is not going to include it in the Oracle's version of Java. Okay.
So do we know how we naming the Java versions like Tiger, Kestrel, Mustang, Dolphin? So not sure what's coming next. How the naming is done to all the Java versions? Any
Um,
pattern?
it's not basically. It's all about like uh, for
Developer.
example, Android version. You talk about Android version, they give it on something to eat, like some candies, basically, right? And for all Android versions, there are some candy names.
Yeah, sweets.
Okay, but here it is not. It is on the feature they are introducing. On the feature they are introducing, like Java 1.5 is feature rich. That there were lots of features have been introduced. So it is called as Tiger. That it has come into picture to give a roaring face to everybody. That coming with a lot of features. Yes,
Yeah.
so that is why they are giving it a name Tiger, right? And then in the Java 1.6, there were some implementations on JDBC4. JDBC4 has been introduced in Java SE6. JDBC4 version. That is an advanced version of Java database connectivity. Then some changes in Java compiler API. Annotations are a very important concept that has been introduced in Java 6. Then Java 7. Java 7 was uh, responsible to bring API, which is NIO. Earlier, we were using Java IO. Then here we have Java NIO API. And along with that, that is we have switch case and exception handling with a new pattern. Like exception handling, we have multiple catch. Like earlier, we were using multiple catch statements. So in this version of Java, from this version of Java, we can have multiple exception handlers in one exception, one catch block, with the help of piping separation. With the help of pipe separation, we can have, like, if one is not catching that exception, other can catch other. So earlier we were writing different catch blocks, so it was increasing the code size, but now it will not. If you want similar kind of message for all kind of exceptions, or you have a message with concatenating with the message which is running getting from the exception, then you can get a exception dot get message that will be returning that particular type of message. So you explicitly don't need to write different catch blocks for all exception handlers. Okay. And Java 1.8, as I've told you, Java 1.8 has come with lots of other features. In that, there are functional interfaces, stream APIs, and for each statement, iteration patterns, and lots of other features which we will be discussing when we will be going through Java 1.8. That what are the different other features we were using in different other Java versions, and what are we using in the current Java version. 1.8 version. 1.8 is one of the very much required version to learn today. If you do not know Java 1.8, you will be lagging behind. Okay. Now, JVM architecture. Here you can see a class loader subsystem and a memory area, runtime data area. Then you can see an execution engine. Then you can see native method interface, and you can see native method libraries. So what native method is? What native thing is basically? Can anyone tell me what native thing is? Anyone can tell me what native thing is?
Native is for the operating system, which we
Right.
Yeah.
Native is for the operating system. We use this terminology when we are interacting with the operating system with some other programming languages, because native implementation is something different, whereas the application development, upper level application development, is something different. So everything which we develop need to be, at some point, need to be converted into native understandable format. So for that, there are native method libraries available, there are native method interface available in this, and we have native method stacks available in the memory. Execution engine is responsible to execute your Java code, and that is with the help of these native method interface and native method libraries. Class loader subsystem is responsible to load your class, and while loading, it does three operations: loading, linking, verification. Okay, so loading, linking, and verification we will be understanding properly. Loading, linking, and verification was happening. Loading and linking was happening in Java as well. Sorry, C as well. If somebody has written C program, so whenever the C program was compiled, it was saying linking when you were pressing Control Alt Shift, Control Alt Control F9 basically. So it was first doing compilation, and then it was saying linking, and then it was executing. So while compilation, it creates an object file, and then particular object file was linking the thing with the libraries, bringing all the libraries, and then creating the execution file. So in the execution file .exe file, everything was there. All the libraries are available with that, and then that particular program was executing. So here also, when we are executing, it was to be first loaded into the memory, verified into the memory, linking it, and then it will be executed. And then all the parts of class, like classes, static classes, method, objects, stacks, threads, and things which need to be in PC registers, all were memory areas were segregated by the JVM, and the relevant information will be stored in that particular uh, runtime data areas. So we will be understanding this in complete detail in the next session. Till then, so if there is any query here, you can ask me, or if you go through this and later come on with some questions, queries, you're most welcome. I'll be trying to resolve your own all queries in the best possible manner.
I have one question for JVM. So in my organization where I'm working, so after every QC to prod migration environment, they are doing some JVM bounce. So I'm not sure what does this mean.
JVM bounce means starting of JVM, restarting of JVM. It's kind of bouncing the server basically, right? JVM bounce means whatever there in JVM, like say JVM is running with a set of with a piece of code. Okay, when you redeploy something, it will not be reloaded until you run it. So for running it, it need to have those things available. So JVM is already having some objects, some memory occupied already for that particular code piece execution. So restarting that JVM uh, will get those new information loaded into the memory and execute it.
Okay, so it's kind of refreshing the program.
Yes.
Okay.
Okay.
Okay, I was always thinking what I mean, always saying JVM bounce needed, JVM bounce needed, then the things will appear.
Yeah, there
Yeah.
are terminologies which you do not know. We even understand the thing, but with the help of with the terminology, we fail. Oh, what is the terminology? Why? What the meaning of this?
Yeah.
Right. In simple term, if I say it is restarting, it is cleaning the memory and whatever it has occupied, it is cleaning that and bringing the new data into the memory. That is what JVM bounces. Okay.
Yep.
Okay. So I'm done for today. I'll be sharing this slides GitHub location.
Thank you.
And you can all go through this. Even you can go with this JVM architecture specification as well. Create your questions and just try to read this. Create your questions, write it somewhere so that you can ask and have some research of yours as well. Might be whatever I'm teaching is there might be some difference with what you understand from some other location. So we will be clarifying that in those discussions. Okay. Guys, this is all done from my side. Thank you for this nice communication and interaction.
Thank
We
you.
will meet in next session. Okay. Have a great day. Thanks.